not going to process this complete picture at a time. Okay, so whenever you are talking about a digital image, guys, what is meant by a digital image? It is nothing but a pixel values. Like it is going to have a pixels, right? So like a number of rows and then columns. So here it is going to have a pixel, right? So this is like a matrix. Okay, you can take it like a matrix. Okay, so matrix of like what to say, it is a pixels. Okay, so matrix of matrix is nothing but a rows and then columns, right? So here out of this picture, it is not going to process this complete picture at a time. It is going to take a certain part of an image. So certain means, so for an example, if this image size in the dimension of let us take it is about 24 cross 55. Okay, so if this is the dimension, so if your digital image size is 24 cross 57, so if it is a size, and instead of processing that complete size, it is going to take only 3 cross 3 matrix. Okay, so it is going to take only certain part of the image or certain part of the original image, and it is going to apply the filter on the certain part of the image. So by processing both the original part and then filtered part, it is going to give us the output value that is known as this convolution layer. Okay, so I hope you are clear with this, guys. So here we have an image. So in the convolution layer, it is not going to process the complete image or complete data at a time. Instead, it is going to take only one part at a time. So first of all, it will take this first 3 cross 3 here, and then it will move this 3 cross 3 here, and then move 3 cross 3, 3 cross 3, 3 cross 3, 3 cross 3. Likewise, it is going to move that certain window towards each and every pixels which are present in that digital image, and it is going to apply the filter on it, and it is going to process the original image with the filtered image, and it is going to give us output. That is known as convolution layer. I hope you are clear with the convolution layer, guys. And what is meant by the pooling layer? So in the pooling layer, we have 3 main types, guys. One is maximum pooling, minimum pooling, and then we have average pooling. Okay, so you just note it down. Okay, so let us give that note. Okay, so here we have different kind of pooling layers. So here we have maximum pooling and minimum pooling, and then average pooling. What does mean by that? It is also simple, guys. So for an example, again in the pooling also, it is going to take a certain group of the matrix. Okay, for an example, so same that, so out of this 24 cross 57 kind of size image, it is going to take only 3 cross 3 matrix, right? First of all, it is going to take a 3 cross 3 matrix. On the 3 cross 3 matrix, if it is going to pick the maximum value, that is known as a maximum pooling. If it is picking the minimum value, that is known as a minimum pooling. If it is picking the average value, that is average pooling. So it's simple. So for an example, guys, you just see here this is the original image. The original image, it is going to take one 2 cross 2 matrix first. On the 2 cross 2 matrix, here there is a 3 1 5 1. So this in this 2 cross 2 matrix, the output is 5. Okay, and in the second segment, like a 7209, second 2 cross 2 matrix, out of that the output value which is 9. Okay, on the third matrix 8243. So in this third matrix we got output 8, and 4911. So in this matrix we got output 9. So you just tell me, guys, what type of matrix is, sorry, what kind of pooling layer is? Is it a maximum pooling, or is it a minimum pooling, or is it a average pooling? Okay, you just tell me your answer. Okay, if you know the answer, you just put your answers in the comment box. Okay, so here another main keyword I would like to say, that is known as a kernel or filter. The kernel means, so here the kernel is 2 cross 2. Okay, whereas here the kernel is 3 cross 3, because 1 2 3 there is 3 rows and then 3 columns. So here the kernel is 3 cross 3, whereas in this example here we have a kernel which is 2 cross 2. Okay, on that 2 cross 2, whenever the value so on the certain group of matrix, so if it is 2 cross 2, so it is going to have 2 rows and then 2 columns. So on the 2 cross 2 columns, if it is going to give the maximum value, that is known as a maximum pooling, and if it is giving the minimum value, that is known as a minimum pooling, and if it is giving the average value, that is known as a average pooling. Okay, and and it's time to reveal the answer. So what is the answer, guys? So answer is, it is maximum pooling. Why it is maximum pooling? Because here we have 2 cross 2 matrix, 3 1 5 1. So out of this 4 numbers, which one is maximum value? That is 5. So the output is 5. And in the second matrix, 7209. So out of that, which is the biggest number? That is 9. So 9 is here. And 8243, 8 is biggest, so 8 is here. And 4911, so 9 is biggest, so 9 is here. So that it has been called as maximum pooling. So likewise here we have minimum pooling and then average pooling even. Okay, so I hope you are clear with the basic layer ideas, guys. If you are clear with the basic layer ideas, you just post I'm super clear Sanjay in your comment box. And while talking about the weights, so weights, you can imagine these lines are known as a weight. So here it is mentioned as W, right? So you can imagine that is a weight. So weights are nothing but it is a numerical value from the neural network machine which is going to learn by itself. It is going to self adjust by itself depending on the difference between the predicted output versus the training input. Okay, so here we have the value, right? So here we have input and here we have the output. So based on the predicted output versus the training input, it is going to optimize itself. Okay, these are all nothing but a numerical value. Okay, so based on that we can able to improve it can able to improve its training process easily. Okay, and another main thing, what is about activation function? So here you just see the structure, guys. So here we have inputs. Okay, so input layer you can take or inputs. Okay, it's just input data, and weights are here. Okay, so weights are nothing but a numerical value which is going to be self optimized. And then here we have net input function. So what is meant by net input function, which is simple. It is kind of like a product of input and then weights plus biases. Okay, let us explore later. And finally we have activation function. So while talking about this activation function, so you just see this picture, guys. In this picture, as I've already told you, the output layer which contains two neurons, which means for an example, the first neuron which is going to represent cat and second neuron which is going to represent the dog. So whenever you are doing a classification, so while doing a classification of the output layer, any one neuron needed to be activated. Of course, right? So on the time it should not show like both neuron which is activated. So if both neuron is activated, definitely that is not a perfect output. Right, only one neuron which is going to be activated and remaining neuron which is needed to be deactivated. So it may be two neurons, it may be a multiple neurons. Okay, so why for activating and for deactivating we used to have activation function. Okay, it is a mathematical formula which helps the neurons to switch on or switch off. For an example which I have already trained, so for an example, if I have already trained my model to by providing the lot of images of pen and a lot of images of hub. Okay, so if I'm going to test it, so if I'm going to give this picture as an input, so on the output, if there is two neuron, only one neuron is going to be activated. So if you have trained with a proper way, then the neuron which is activated, which is going to represent that it is a hub neuron. Okay, so to activating a certain neuron, we need a certain kind of function which is known as activation function. While talking about activation function, here we have lot variety of activation function. First of all, here we have step function. So while talking about the step function, so based on the input, so you just imagine x is going to be your input. If value of x is greater than or equal to 0, okay, if the value of x is greater than or equal to 0, then output which is going to be 1. So for an example, if your what to say, if your x is 0.99, 0.98, it is, if it is greater than or equal to 0, then output is going to be 1. But whereas if the value of x is less than 0, like -1 or -2, something like that, then the output of this function which is going to be 0. Okay, that is known as a step function, guys. So here you can able to see this picture. Okay, if the input is 0 or greater than 0, so then output value which is going to be 1, or else it is going to be 0. Okay, so if it is negative, then it is going to be 0. Okay, so and then while talking about the sigmoid function, so you just see this graph, guys. So if out of the graph itself, we can able to easily identify that if the value of x is infinity, then output is 1. Whereas if value of x is negative infinity, then output is 0. Okay, and its range is different because there is similarity between sigmoid and then softmax. Okay, you just understand about the range. So while talking about the sigmoid function, so it is having the range between 0s and 1, whereas in the softmax it is going to be different. Okay, so you just don't forget one thing. So if the value of x is infinity, then output is 1, and if the value of x is negative infinity, then output is 0. Okay, it is also going to capture non-linearity in the data. It can use the gradient descent and backpropagation method to calculate weights. What does mean by this? So for an example, guys, so there are some of the problems in the neural network, like a vanishing and then exploring gradient. So these are all the major problems. So for example, what is meant by the vanishing and then exploring gradient is, for an example, if you have some data, guys, okay, so you have the data which is 0.02, Okay, so for an example, on the first layer itself, a certain neuron value or certain value which is all in the name in the value of 0.05. Okay, if it is so, then whenever it is going to process towards each and every layers, that value, if it is reduced to 2.01 or 0.001, so something like that, definitely that value which is going to be disappeared. Okay, so disappeared is like vanishing. Okay, that is known as a vanishing and then exploding gradient, so that your output will turn to 0. So to have the understanding about the previous output, we used to have the methods like a back propagation. So with the help of that, we can have a track about the previous value, so that we won't miss that value which is very less. That is the main advantage over here. Okay, so we can able to avoid that. So we can able to avoid that vanishing and then exploding gradient by seeing the previous values. Okay, so and then softmax function. So while talking about the softmax function, it is it's also having to have some formula. So same as like its layer which is also going to be different. Okay, it is used to map the non-normalized output of the network to a probability distribution over a predicted output class. So it may be multiple classes, and so it may be different classes, and that it converts output of the last layer into the essential probability distribution. So while talking about the softmax function, guys, its output which is going to be like a essential probability distribution. So for an example, guys, I'm going to have the same two object like pen and then this USB hub. Okay, so final layer, and the final layer we are going to have a two neurons, of course, right? So one neuron is going to represent a pen, another neuron which is going to represent this hub. So on that application, whenever so on the output layer, it is going to try to find out the probability distribution. So for an example, the first neuron's probability is 0.98 and second neuron's probability is 0.32. Okay, so if it is so, then what it will try to do is, with the help of the softmax function, it will try to find out which neuron is having a maximum probability. Of course, the first probability or first neuron which is having the maximum probability, right? That is 0.95, right? So with the help of that, so it will come to a decision that we need to activate that neuron instead of activating the remaining neuron. It will deactivate the other neurons. It is going to activate only the one neuron which is having the maximum probability. Okay, this softmax function which is especially about a probability distribution. Same as like here we have tan-X function, ReLU function, and etc. Okay, likewise we used to have lot of activation function, guys. So based on our requirement, we need to choose what kind of activation function we are going to use. And hyperparameter. So as we have already discussed about the hyperparameter, guys, but here in deep learning applications, what is meant by the hyperparameter is, what are the hyperparameters? So I think we all know what is the purpose of using tuning hyperparameters. It's simple. For an example, if you are getting 95.3% accuracy, but still now if you want to increase your accuracy further, you can tune your some of the hyperparameters to get your accuracy to the further level like 99.1% accuracy. So for that, there are a lot of methods or a lot of ways. So one is like a dropout. So dropout in the sense, if you want to remove the certain neurons and those things, that can be removed with the help of dropout, and then changing an activation functions and changing a learning rate and changing a number of epochs. So number of epochs in the sense of, for an example, same as like these two objects. I have collected 1000 images of pen and 1000 images of this hub. So totally I have 2000 images. So whenever you are doing a training, so number of epoch means how many iteration need to be trained for like complete 2000 images. So that is known as epoch. So you can change or you can increase your number of epochs to observe the change. And batch size. So for an example, if you are going to process the certain image, how many batch it should take at a time. For an example, if you are using maximum batch size, definitely you will get an error like memory error if you are using normal PC. So you can use better if you are using low-end CPUs or low-end system. So you can reduce that batch size to very less, so that it will reduce your computational power and number of neurons. So you can also tune your architecture, like your neural network architecture, so that that output or the performance of your model will also going to be changed. Okay, so likewise here we have this activation functions, weights, neurons, layers, and we have also explored the hyperparameters. Okay, and now we have some types, guys. While talking about these types, here we have different types here. So for an example, first of all, here we have perceptron. This, if you are seeing this architecture, it is looking like very simple, right? It is the simplest and oldest form of the neural network, where it can't able to classify more number of complex based images. Okay, it's simple neural network. And second, we have multi-layer perceptron. So multi-layer in the sense it is going to have multiple layers which contains like input layer, hidden layer, and then output layer. Whereas this, it's decision function which is going to be a step function. So that the output is binary. So what is meant by a binary, guys? As we have already discussed that binary, what is meant by a binary classification? It may be either cat or dog. So there is no any probability of cat or so any possibility of cat or dog or hen. Okay. So it is completely about binary classification. That is a multi-layer perceptron. And feed-forward neural network, it is also a simplest form of neural network which is basic for the neural network which we are going to explore later. And whereas this input of data, so the input data, whenever you are giving some data, it is going to travel on only one direction throughout the output layer. So for example, if you are giving the input in the x1 or input layer, it is going to pass to the hidden layer and then output layer. There is no feedback to have notice about the data or having a notice about the values. Okay, that is a feed forward neural network. Feed forward means the data which is going to be passed towards the one direction. And then convolutional neural network. While talking about this convolutional neural network, which is going to have three-dimensional arrangement of neuron. Okay, so it is not a three-dimension, right? But whenever talking about a convolution layer, it is going to have three dimensions. Okay, so if you are seeing this picture on close, you can able to easily understand this. Okay, it contains a three-dimensional arrangement of neuron. Okay, so here we have layers. This is like a sample architecture. So here we have input layer, and here we have hidden layer, and finally we have output layer. So here the input layer, we have given an image which is a car image, and here we have multiple layers like convolution layer, pooling layer, convolution layer, pooling layer, and then flattening process, fully connected layer, and softmax. So likewise, we have extracted, we are going to classify that, and in the output layer here we have classes like car, truck, van, bicycles, and etc. Okay, so as we already know, CNN, which is not going to process the complete image, it is going to take a certain part from the image and it is going to process only batch by batch. Okay, that is the main thing about this one. Okay, so each neuron processes the information from a small part of a visual field. Okay, it is not going to process the complete thing. So this convolutional neural network, which is completely or majorly focused on images, because it is having a three-dimensional arrangement of neurons, so this it is going to mainly focus on images. Okay, and then here we have radial basis. Okay, so here we have radial basis neural network. So while talking about this radial basis neural network, so here we have a single perceptron. So for an example, it is going to look like normal neural network, where it is going to transform the input signal to the another form, which can be then fed to the network to get linear separability of the data. Okay, so and it is also going to have only one hidden layer. Okay, so that is about a radial basis function. And here we have recurrent neural network, guys. Okay, you just come into the session, come into here, you just see the two picture, guys. Recurrent neural network picture is here, and feed forward neural network picture is here. Okay, you just try to tell me, you just try to find out what is the difference between these two neural networks. Know the answer, you can put your answers in the comment box. Okay, here we have feed forward neural network, and here we have recurrent neural network. Okay, what is the difference between the picture, guys, or architecture? Okay, what is the main difference is, here we have feedback. So here we have neuron, so like input, hidden, and then output. So here we have some feedback over it. So that is the main advantage of using recurrent neural network, guys. Okay, so from that you can come to the decision that whenever you are handling some text data like chatbots, if you are creating a chatbot, voice assistants, and those things, you can use this recurrent neural network. Okay, for an example, guys, if I'm telling to my voice assistant like, hey Siri, what is the time now? Who is the president of India? So if I'm asking some of the questions like what is the time now, so even that now text which is not being recognized properly, it can able to automatically identify that. Even in your Google also, you are typing something, what is mean by ARTIF, so automatically it will give you the suggestions like artificial intelligence. So it is based on the recurrent connection. So it is learning, it is not missing any data which is done previously. It is going to predict the upcoming data based on the previous data. So that is the main advantage of the recurrent connection, since it is having the feedback. Okay, like it is going to see the previous data. So it is having a feedback. That is the main advantage of this recurrent neural network. Okay, and then libraries. While talking about these libraries, guys, so first library which we have, TensorFlow. This TensorFlow is which is by Google, guys. Okay, this TensorFlow is a numerical computational library which is going to use data flow graphs which is also going to be used as like a standalone, as well as you can also use this TensorFlow as a backend, which is also having ability to like distributed computing on multiple GPU. And I hope you all know about the GPUs, guys. So I hope you have heard it. So what is the GPU and then CPU? So why they are nowadays a lot of people are talking about the GPU. So I would like to share that knowledge with you. So for an example, guys, the same is like if I'm going to classify the apple and then banana. Okay, I have 2000 images, 1000 images of apple, 1000 images of banana. If I'm going to train with my normal PC, it may take 1 week. So for an example, okay, so my PC, so I should be aware of a lot more things like power, so it should not be turned off. So likewise, there are a lot of conditions are there. So we just want to train it. So I'm going to train that 2000 images. If it is going to take 1 week, 1 week for completing a training. For an example, if I'm going to train the same thing in my GPU, it may complete within 20 minutes. That is the main advantage of the GPU. Okay, so while using the TensorFlow, here it has the ability like doing distributed computing on multiple GPU. Means if you're having a certain GPU, you can distribute the work and you can able to complete it very fast. So for that, you can also use this TensorFlow library and Keras library. This is also one kind of framework for the deep learning, where the advantages such as like if you are writing the program for the CPU, same program can be written in the GPU as well. Same program you can use it for the GPU as well. And this Keras, it is going to use the TensorFlow and then our Theano as a backend. And it is not main disadvantages. It is not going to support multiple GPU. Okay, and Torch. So you may heard about like PyTorch and those things, right? So it is an old machine learning and deep learning library, which is also going to support CUDA. So how many of you guys know about the CUDA, guys? Compute Unified Device Architecture. So it is like a parallel processing and those things. So for an example, and another thing. So how many of you people know about the NVIDIA? So we used to play a lot of games using NVIDIA graphics card, right? Now they are more popular on creating boards for artificial intelligence. So if you are going to use the development boards, that kind of NVIDIA board in your laptop, so sometimes you may require this applications like CUDA. So you just want to install that CUDA in your laptop. That is Compute Unified Architecture. This PyTorch will support that CUDA programming. Okay, so for parallel computation and the supervised image problem with the CNN. So other problems like whatever the things, guys, whatever the application, you can choose any framework to train it. And here we have Caffe. So Caffe is a deep learning framework which made with expression, speed, and then modularity in the main. So for an example, guys, while comparing it with the other frameworks, this Caffe framework, which is really fast on doing a classification, it is also going to support CPU and then GPU. And then MXNet. This Apache MXNet is an open source deep learning software framework. Same, it is also one of the framework which is going to useful for same like doing a training and then deploying deep neural network. But it is having a more number of natural like programming or language bindings. Okay, programming language bindings. So it will also support like C++ and those things. So likewise, it is going to have more number of language bindings. Okay, which is also having ability to do a distributed computing. So distributed computing in the sense like parallel processing those stuffs. And here we have another library called NumPy and then SciPy. So what is meant by this NumPy and then SciPy? So NumPy means numerical Python and SciPy means scientific Python. I hope you all familiar with this, right? So these are all the majorly used libraries, guys. And here we have applications as we have already discussed, like fruit and then vegetable classification. So for an example, if you are cultivating a lot of fruits, if you want to classify that fruits, even though they are nowadays they have deployed a lot of artificial intelligence robots where it can able to segregate good fruit and then rotten fruit within a second, within a minute, within a few hours, it can able to classify that huge amount of objects. So for that we can use an AI in cooking. So AI in cooking, in the sense nowadays industries use to analyze the molecular structure of the food, guys. And how many of you people are vegetarian here, and how many of you people are non-vegetarian? Okay, I think a lot of most of the people are non-vegetarian, right? So here, what is the thing is, while using that non-vegetarian product, so there is some kind of a problem in there. So what is the thing is, some of the industries are making a non-vegetational product without using that non-veg. So it's simple. For an example, they are making chicken gravy or chicken something. Okay, so they are making chicken dish without using that chicken. Instead they are using some vegetational product. Definitely you will get scared about, you will get surprised that how can they create it. So it's simple, guys. Well, whenever you are tasting a chicken or whenever you are eating that dish or any non-veg product, So what are the basic things? So you will have the constraint like it should have taste. Taste is the first priority, right? So taste, and then smell, and then texture. So how it is look like? Is it like a gel or something like that, right? So these are the what to say? Like what to say? These are the features, right? These are the things. So what they are doing is they are analyzing the molecular structure. Okay, they are analyzing the molecular structure of that chicken product, and they are comparing it with the same kind of molecular structure which is all present in the vegetational product, and they are manufacturing or they are making the same kind of chicken. Whenever they are providing it to the peoples, they used to taste it and they are not feeling that that is a non-veg, that is a vegetational product. Okay, they are recreating the non-vegetational product with the help of a vegetational product. Okay, that is known as AI in cooking. And AI in an autonomous vehicle, of course, I think we have already discussed a lot of challenges in like there. So like lane detection and then tracking, obstacle avoidance, road sign recognition, and then what to say, traffic light detection. So likewise here we have a lot of challenges. That challenges can be overcome with the help of artificial intelligence, especially deep learning and AI doctor. So you can put up some thermal camera in the COVID times. So we can put up or we can create one robot. So that robot, whenever the person going to enter into the hospital or enter into your house, so it will automatically analyze the person. First of all, it will try to identify the person. After identifying the person by using a thermal camera, it will try to identify the temperature. So with the help of that, it will automatically give the suggestions like you are having a maximum temperature. Do you want to consult a doctor? So when do you need appointment? So what is your question? So likewise, you can combine natural language processing with the deep learning application to create these kind of artificial intelligence based doctors. And the prediction of disease from medical image. So it is also, we have already discussed in Madurai, there is a hospital like Arvind Eye Hospital where they are already collecting a database of diabetic retinopathy, where it is like a blood leakage will be in the eyeballs. So likewise, medical image processing. So for an example, if you are doing it with a manual way, so doctors will use to observe from the medical image, and they'll try to give the suggestions like there is no diabetes or like diabetic retinopathies for you, and for you who you have that base, you are in the basic stage. Likewise, they'll give a suggestion. But if you are using this kind of program where it can able to predict previously itself, okay, which we can't able to understand from the image, where with the help of this artificial program it can able to do that. So that is the main application over here, guys. Okay, so I hope you are clear with this, guys. So I hope you all super ready for the hands-on also. Okay, so let us go for the hands-on. Okay, and another main thing, guys, so here I have already installed some of the libraries. Okay, the libraries such as like I've installed Keras. Okay, let us open now. Okay, I have two test programs. So this project is Pima Indians diabetes detection. Okay, so these are the things we are going to explore later. Okay, but before that, you want to know about the some of the libraries and those things. Okay, so what is about the libraries? We have already discussed about the libraries, right? So libraries in the sense what to say, here what is the libraries in the sense like TensorFlow and then Keras. So these are all the libraries we need to use, right? So first of all, we need to install that library, right? So I hope you all know about like how to install a library, right? So pip install TensorFlow, pip install Keras. So whatever the library you need, you can use it or you can install it with the help of that command. Okay, so please complete your installation. So first of all, install your TensorFlow and then try to install Keras. Okay, so I'm going to open my command window. I'm going to check it out. What is my version? Okay, so Python. Okay, enter and import TensorFlow. You just use this version, guys. Okay, it is also really good. Okay, so I'll check it out and I'll tell you the version. Okay, you just please install this TensorFlow version. I hope you all know how to install the TensorFlow, how to install the library, right? So on the command window, so if you are using ideally, if you are using PyCharm and those things, you just open your command window as an administrator and type pip install TensorFlow or pip install Keras, that library name. But if you are using Google Colab, you can put up exclamatory and you just put pip install that library name, right? So now I'm going to install Keras now, import Keras now. Import Keras. Okay, two things which is already installed now. Okay, so Keras and then TensorFlow. Keras. If you are seeing here, Keras which is using TensorFlow as a backend. as I've already told you. Okay, so now I'll tell you the version, guys. So based on the version, you just try to install that. Okay, so let me check the version. So TensorFlow dot underscore version underscore enter. So this is the version of the TensorFlow which I'm using here. Okay, TensorFlow version is 1.14.0. Please note it down, guys, because lot of people are used to face the problem. Sir, Sanjay, I'm getting the error like TensorFlow and then Keras, which is not matching with each other. So that's why I would like to give this version in detail. Okay, so please note down this version. Keras.version. Okay, so please note down this, guys, or please take a snap of it. So what is the TensorFlow version, which is 1.14.0? What is the Keras version? That is 2.2.4. Okay, so these are the version which I'm using here. Okay, please install this version. So I hope you all know how to install library based on the version event, right? So you just simply open the command window as an administrator. So I can able to show it to you. For example, we are using ideally this command prompt as an administrator. Okay, guys, as I've already discussed with you guys, for my personal side, so I won't use Google Colab for deep learning application. I'll use PyCharm or this command window for executing the program. So for deep learning, okay, so that's why I'm executing here. So I'm not doing in Colab. Okay, so how to install based on the version, guys? So it's simple: pip space install space TensorFlow. So the people who already installed the Python, and if you people who are who haven't installed TensorFlow and then Keras library, I'm showing it for you. So pip space install space TensorFlow double equals to 1.14.0. You just click enter. Okay, guys, if you want to uninstall the previous version, you please use the command pip space uninstall space that library name. So that library will be uninstalled. Okay, if you want to reinstall it, please uninstall the library first and then reinstall the original version. Okay, or reinstall this actual version. And if you want to install the Keras in the specific version, so pip space install space Keras double equals to 2.2.4. Okay, I've already installed it. Okay, I hope you completed your deep learning installation. If you have completed your installation, you just post I completed installation Sanjay in your comment box. Okay, or else if you are facing any error, you just post this error screenshot on the comment box below. Okay, so I hope you are clear with this. We have finished our installation, and now let us go for this program. So what is this program? Is this project which is about diabetes? Okay, diabetes detection, which is happening for the women. Okay, so so here which is occurring for the women's, like, okay, so here we have this data. So here there are a lot of ways, guys. You can use normal numerical data, as well as on the tomorrow session also we are going to discuss with the image, or we are going to work on with the deep learning algorithm with the image. Okay, don't worry about while handling about the image. Definitely I'll teach you. So before that, here we have this numerical data. So here each and every column which is representing a certain state. For an example, the first column which is representing like number of pregnants, and second column which is representing plasma glucose concentration, and this C column which is representing diastolic blood pressure, and the fourth column which is representing tricep skin fold thickness. So likewise, each and every column which is representing a certain data. We are not a medical student. Okay, we are not going to bother about it. Okay, and here we have final class. So final column which is going to represent the class. Here we have either 1 or 0. So what does mean by 1? 1 is means the person is having a diabetes, and 0 means the person is not having a diabetes. Okay, so 1 means the person is having a diabetes for this data, and 0 means not diabetes for this data. Okay, likewise here we have binary classification 1 or 0. 1 means diabetes, 0 means not a diabetes. Okay, and what we are going to do is, in this program, first of all we have imported a NumPy library which is going to be helpful for loading this CSV file into our programs. I hope you all know. And then Keras.models import sequential. So we are going to use the sequential methods, like we are going to build our neural network from the scratch. So that's why I'm using the sequential. And Keras.layers import dense layer. So we are going to use the dense layer, and the dataset is equal to load text of PMA Indians diabetes.csv. I'm going to use this dataset file. I'm going to load the dataset file, and comma delimiter is equal to comma. So based on the, because it is a comma delimiter based CSV file, so that's why we are going to have the delimiter which is comma. Okay, and here we are going to segregate our data. So input and then output. So same procedures, guys. So these are all going to be my input, and this is one is going to be my output. So we are going to segregate our data, dataset colon comma 0 to 8, which means 0 to 7, and 8 column which is y. So these are all going to be my input, and this one is going to be my output, data set segregation. And what to do now? What we are going to do, we are going to start building our neural network from the scratch. So for that, first of all, we need to initiate with model is equal to sequential. Okay, so sequential is here, and after that model dot add of what to say, so first dense layer of 12. So what does mean by this 12 and input dimension is equal to 8? It is simple. So you just to see this mind map. So in this mind map, here we have 3 input layer, 4 hidden layer, and 2 output layer, right? So while seeing this image or this architecture, what is the architecture will do is, since the input dimension is equal to 8, it will create 8 red color neurons. And since dense of 12 here, it is going to create 12 blue color neuron. Okay, first 12 hidden layer. Okay, that is the meaning of dense this line. Okay, so we have created 2 layers. Input layer, which is input dimension, which is in the size of 8. So 8 red neuron, and then 12 blue neuron, that is the first hidden layer. And then here we have activation function, which is ReLU. Okay, so let us leave it. And then second hidden layer, which I'm going to add, I'm going to have another intermediate. Here we have only 3 layers, right? So here we're going to have 4 layers, where another hidden layer, which is going to have 8 neurons. And model dot add of dense of 1 comma activation is equal to sigmoid. So why here we are using here sigmoid is because the classification is a binary classification. So that's why we are using the sigmoid activation function. Okay, and model dot compile of loss is equal to binary cross entropy. So here we are going to compile our model by using optimizer called Adam optimizer, because it is really detailed, guys. There are a lot more things we need to learn on the deep learning on specific. Like there are different optimizers even. Here we are going to use the Adam optimizers and matrices, which is accuracy. Based on that, we are going to do the binary classification. We are going to compile our model, and here loss is a binary cross entropy. And here this step, this is the main thing, guys. So model.fit, I think we have already discussed that. This is going to be helpful for doing a training process. Okay, so while doing a training process, so here we have model.fit of input, which is x, and then y, which is output, and epoch is equal to 5. So epoch means, as we have already discussed, how many iteration need to be throughout, how many iteration need to be happen on throughout the complete data, that is epoch. So here we have given 5 epoch. So since for demo purpose, I've given only very less number of epoch, and batch size is equal to 10. So I'm going to give like how much data I need to process at a time. So that is a batch size. And then we are going to evaluate our model. So model dot evaluate. So what is our model's accuracy? So once the training is completed, it is going to give us the accuracy. What is our model's accuracy? And then what we are going to do, we are going to save our model in our local directory, so that you can able to reuse it for testing or doing a prediction or doing a classification at the test site. So that's why what we are going to do, we are going to save our model in the format of like model.json and model.h5. So we are going to save our model core value in the model.json file, and we are going to save the weights in the model.h5. Okay, it is your option, so you can use either any files. Okay, so I'm going to save it in the 2 formats, like .json and then .h5, so that the model will be saved in my local directory, like model.h5 and model.json. Okay, for an example, let us delete now. Okay, it is pre-trained, which is already trained before. Okay, now I'm going to run this. Okay, CMD, I'm going to run it from the command window, guys, because it won't consume more computational power. So that's why I'm using here. Okay, because if I'm using PyCharm, definitely it will consume more power. Okay, so I'm going to run the test train program, python space train.py. Okay, it is taking time to load that TensorFlow and then Keras library. Okay, if you are seeing here, the 5 epoch 5 iteration which is completed, but because the data set which is also very less, guys, only a numerical data, so that's why it completed the training process very fast. Okay, so here we got 66.02 accuracy. Okay, so for first epoch, what is the accuracy, what is the loss? And second epoch, what is the accuracy, what is the loss? Third epoch, what is the accuracy, what is the loss? What is the accuracy, what is the loss? Likewise, it has been trained for 5 epochs, and accuracy which we got is 66.02. It is really it is not a good accuracy. Just for demo purpose, I'm doing that, and I'm also going to it for testing program, because if you are doing a lot of complexity in your training program, it may take more time. Definitely, we'll explore on the tomorrow session by having a complex data set, which is COVID detection. Okay, but here it is simple data set, and what we are going to do is here we are going to go for testing program. Okay, so what we are going to do is we are going to load some data from the data set, and we are going to test it whether it is doing a right prediction or wrong prediction. Okay, so for an example, so out of this Excel sheet, the CSV file, we are going to take any 5 data. Okay, so we are going to ask our model to classify, because it already got that intelligence, right? So these 2 files which now occurred here, okay, which means it is a trained model file. And now what we are going to give, we are going to give 5 random data. We are going to give five data from the data set itself, and we already know the actual data. So from that we are going to compare it, whether which one is right and which one is wrong. So likewise we are going to do the classification, or we are going to understand how the testing program is for us now. Okay, so same lines. So load text to load the data set, and to load the model from the JSON file, because the model which is already saved in the local directory, to load that we need the library like keras.models, import model from JSON, and the data set which has been loaded, same line, and x and then y segregating of data, and we are going to load the model by using the 6 lines. So R means read. Okay, we are going to read the data and we are going to save it in the single variable called model. So now that model will have the complete intelligence about which we are already trained before, which is nearly like 64% accuracy, right? That is 66.02 accuracy. Okay, so that high intelligence which is all present in the model file, and we are going to do the prediction. So prediction is equal to model.predict underscore classes of x. So what is mean by x? So x is the complete data. So we have already segregated that input data, right? But what we are going to do, we are going to compare only 5 results. Okay, so we are going to take 5 to 10 rows. So only 5 to 10 rows we are going to take the data, and we are going to print the original result versus the prediction result. That is the meaning here. Okay, so prediction results versus the original result. So let us see the output, so then you will understand that. Python test.py. Okay, it is going to give me the results, guys. So like for 5 days, 5 data. Okay, so we got the output. So for the first data, the output, the predicted output is 0. Actual output is also 0. It is good. So out of 5 marks, our model score 1 mark. Okay, and the second line, so for this data, actual class is 1. Actually the person is having a diabetes, but our model is given that is the answer is 0. That is wrong, right? So and then third class, actual class is 0. Output is 1, so it is also wrong. Okay, it is also wrong. And then fourth output, which is also wrong. And final output, so original class is 1 and our model given the answer that is 1. So out of 5 marks, our model got only 2 marks, because the accuracy is also not good. Okay, so for that you can tune some of the parameters. So what are the tuning parameters? You already remember the methods, right? So we need to go in depth for that, to master the deep learning projects or deep learning algorithms. So here, what is the thing? You can change or you can increase your data set, or you can tune some of your neural network, or you can add some more layers to extract the features. So likewise, you can tune some of the parameters to get us output. Okay, so I hope you clearly enjoyed about this output, clearly understand and then enjoyed up to this program. Okay, this project session where we have done diabetes classification by using a simple neural network design. Okay, so I hope this simple neural network which is designed within 5 minutes, right? So I hope you clearly understand. I hope you really enjoyed this session. So if you really enjoyed this project, you just put I really enjoyed Sanjay in your comment box. Okay, so and then we are also providing this 30-day success mindset, right? We are already doing it. So yesterday's task is about practical task, which is about write down you list of bad habits and tear the paper and burn it, right? And then today's success mindset, which is about write down the list. This is what I love most about my life, because up to now what we written, guys, what we wrote, so we wrote like what we really want and what we already have. But now what we are going to do is we are going to write what love the most, which I already have in our life. So for an example, you may write about like your parents, or your economical status, or your studies, your memory power, or your skills up to now. So what you are like in based on which about you are feeling happy or you are feeling love about. Okay, I love most about my life. Okay, you just put I love most about my life, and what is that, what is the thing. Okay, so so that is the thing. So likewise, you just write down what are the points you can write. Okay, please write it down and feel somewhat thankful to it. Okay, so say thank you. Okay, for an example, if you are writing that I love most about my life that I got my good parents or supportive parents or encouraging parents. So like if you are writing that, please say some thank you. Okay, so just simply say thank you. Okay, don't try to focus on negative things, guys. As we have already discussed that, don't focus on sorries and a last warning and something like that. Please try to focus on the positive things. You just give some thank you, so that you are going to receive, you are going to give lot more thank you hereafter. Okay, because you are going to receive that much of things, so that you are going to give thank you to them. Okay, even if you are seeing some people like your security guard on your apartment, or some people, or the cleaning people, so you just tell one thank you for them. Okay, that is a practical task of today's success mindset. Okay, because whenever you are telling some thank you, definitely it is going to be helpful for you. Okay, for this I can tell you some short story, guys. So what is the story is, I think I've seen in LinkedIn or something. I didn't for I totally forgot it, but I remember that story. Okay, so I just there is one company. Okay, so some cool and some industry based some companies there. Okay, on that company, so there is a security guard, of course, right? So whenever people used to come in and walk out, they are not taking care, or they are not respecting the people who are guarding our office or our industry. Okay, there is a watchman or a security, so they are not giving some response to them. So they are simply going here and there. They are not at least telling good evening or good morning or thank you. But a certain lady who is used to tell thank you and good evening and good morning each and every time whenever she used to walk over that gate. Okay, on morning she'll tell that man good morning, and in the evening she used to tell good evening. Okay, likewise, whenever in each and every day, she didn't miss any day to say good evening or good morning or telling a thank you for that certain specific security person. Okay, so it is happening there. Okay, on the certain time, suddenly on one day, that security guard minds got breaked out that certain person, still now I didn't receive that good evening from that person. Actually I received good morning from that person in the morning, but still now I didn't receive good evening from that evening. So he's that point that is getting striked over to that security person. So suddenly what he did, he just gone into that industry, and he just look for her. Okay, so he just randomly he just look for her. Where is she? Because whenever she used to cross that gate, she used to tell good evening. But today, still now, there is no good evening for me. So he used to search for her. So on the time, he find out that that lady got stuck onto the certain frozen container. Actually, that is some kind of industry where that girl was completely stuck on that frozen container. Someone accidentally closed that frozen container. If that security guard missed to watch her, definitely she might be dead. So it is really impressed me. Okay, whenever I used to watch that secret movie, or whenever I used to read that kind of motivational or thankful, that kind of book, this story linked to that point. Okay, it may be cleaning people, or it may be security, it may be your like what to say, any servant or any servers. Please tell at least some thank you, or please at least tell some good evening or good morning. Okay, so that's a great story, right? So I hope you love the story. If you love the story, just post I love Sanjay, I love the story Sanjay in your comment box below. So thank you once again. Thank you so much. It's me Sanjay signing off. Until then, bye. We'll see you on the tomorrow session.